Good morning, children. Hope you all are safe, staying healthy, and maintaining social distance. Last class, you had read about physical changes. Physical changes in which no new substance is formed, sometimes it can be reversed, or only the physical properties such as shape, color, size, and state of matter is only changed. These type of changes are called physical changes. In this class, we are going to study next is the chemical change. The very common and most common example which you already must have seen in practical is rusting or jung lagna. This is what we are going to read first. A change with which you are quite familiar is the rusting of iron. If you leave a piece of iron in the open for some time, it acquires a film of brownish substance. You all know jung lagna, when iron is left along with the moisture and air, there is a brown substance or powdery substance forming over the iron, which is not iron. This substance is called rust, and the process of forming rust is called rusting. Iron gates of parks or farmlands, iron benches kept in lawns and gardens, almost every article of iron kept in open gets rusted. At home you must have seen shovels and spades, all are made up of iron, getting rusted when exposed to the atmosphere or air for some time. In the kitchen, a wet iron pan often gets rusted if left in that state for some time. Any iron material, if you leave it in sun or leave it in moisture or leave it in air, after some time it will rust. Rust is not iron. It is different from iron on which it gets deposited. Let us consider few more changes. Now we have to read about few more changes which are chemical changes. In activity form, equation form. Activity given, here is an equation, we'll go through it. Get a small piece of thin strip or ribbon of magnesium, clean its tip with sandpaper, bring the tip near a candle flame. It burns with a brilliant white light. When it is completely burnt, it leaves behind a powdery ash. What is here? Magnesium ribbon. If you would have been in class, I would have shown you, but as it is not possible at home, so I am verbally telling you, I hope you understand. Take a magnesium ribbon. Now clean the magnesium ribbon with a sandpaper and then burn it in a candle, in the flame of the candle. What you will get is a grey color ash, and this grey color ash is MgO or magnesium oxide. Here it is shown in reaction form. Magnesium plus oxygen will give magnesium oxide. And this arrow, this depicts becomes. Here is an arrow given which means it becomes. This, adding to this, it becomes magnesium oxide. Now next, now this magnesium oxide which is formed, the ash which is formed, it has to be diluted with water. Let us read. Collect the ash and mix it with small amount of water. Stir the mixture well. Test the mixture with blue and red litmus paper. That means now we have to check the nature of that solution. The ash mixed with water. We have to check the nature of that solution, whether it is acidic or basic. But first we should know what it is formed. Then you can easily tell whether it's acidic or basic. What is formed? Magnesium oxide, the ash, when it is mixed with water, arrow means becomes, it becomes magnesium hydroxide, MgOH2. Now you all know calcium hydroxide, be it sodium hydroxide, magnesium hydroxide, they all are base. So this will be, nature will be basic. So what it will turn? It will turn red litmus blue. As you have already learned in chapter 5, magnesium hydroxide is a base. So magnesium oxide is a new substance formed on burning of magnesium. Magnesium hydroxide is another new substance. So here two new substances are getting formed. First, it is forming magnesium oxide, and when diluted with water, it forms magnesium hydroxide. Now there is one more activity and one more equation to be shown. That is, dissolve about a teaspoonful of copper sulfate. Now taking copper sulfate or blue neela thotha, what it is called, blue vitriol also it is called, and it has to be diluted in about half a cup of water in a glass tumbler or a beaker. Add a few drops of dilute sulfuric acid to the solution. What is dilute sulfuric acid? Water mixed with H2SO4. This is dilute sulfuric acid. You should get a blue colored solution. You are getting a blue colored solution now. Save a small piece of the solution in a test tube or a small glass bottle. Drop a nail or a used shaving blade into the remaining solution. What you have to do, take it in two parts. In one part, leave it as it is. In the other part of the blue vitriol solution, Put an iron nail or a shaving blade. Observe it for some time, leave it for some time. What it is formed? Now let us see. CuSO4 solution you were having, copper sulfate solution. When iron was added to it, iron nail was added to it, what happens there? Displacement reaction takes place. As iron is more reactive, so it will displace copper from its solution. The one which is more reactive or more strong, it will displace the weaker one from its solution. So iron is displacing copper from the solution, so it is forming iron sulfate, and copper gets deposited on the nail or blade, whatever it is. So this change of the color will be green, and this green solution will be iron sulfate. Is that clear, children? Do you see any change in the color? Yes, it becomes green color. Take out the nail or the blade. Has it changed in any way? Yes. A brown deposition is there on the blade. The changes that you notice are due to a reaction between copper sulfate and iron. This type of reaction is called displacement reaction, which is not there in your book, but you should know. The change of color of the solution becomes blue to green is due to the formation of iron sulfate, a new substance. Again a new substance. Whenever a new substance is getting formed, that means it is a chemical change. The brown deposit on the iron nail is copper, another new substance. We can write the reaction as, now it is formed in the reaction CuSO4 plus iron, that is Fe, becomes, this shows becomes iron sulfate, that is FeSO4 plus copper. This is the reaction. Iron displacing copper from its solution and forming iron sulfate and copper. So that's all for today, children. Next class will again start off with activity 6.8. Happy reading, children. Read the chapter thoroughly. If you don't understand anything, please ask me. Thank you, children.